Still solving these polynomial equations, but in these examples, they give us one of the solutions. So when we examine this, first thing that we should identify is, first of all, it's a 4-term polynomial. So really the only method that we have for 4-term polynomials is factoring by grouping. If you start to examine these and start the process of factoring by grouping, you'll very quickly see that you do not end up with the same linear factor. So factoring by grouping is not going to get us there. But there is something that we can do with factoring here. All of these have an x in them, right? So that's step number 1. We need to pull out that x. So we do that. And we get 2x cubed minus 3x squared plus 5x minus 2. Okay. Again, kind of going back to that factoring by grouping conversation that I was having, it is 4 terms. It is a cubic. So we are thinking factoring by grouping, but we would not end up with that same linear factor. So not factoring by grouping. We do get one solution of x equals 0 from that GCF of x right there. Let's glance at the graph real quick and get just some direction as far as what else is going on. So I already have this put into Desmos. When we look at it, it's a 4th degree, but when we look at the graph, it kind of looks like a parabola. So we see a 0 at 0. We've already gotten that one. There's also 1 at 1/2 that was given to us. It doesn't cross the x-axis again, so that means those other 2 are imaginary solutions. How do we get those imaginary solutions? Well, we're going to use a little method. Since we know that 1/2 is one of our zeros or one of our solutions, we are going to use something that you learned in Math 3, you may remember or may not, that says if something is a 0 of a polynomial, when you perform synthetic division, or long division, however you want to look at it, your remainder will be 0. So we're going to set that up. 1/2 is a solution to our equation, and so, I mean, it's given, but I'm just going to rewrite it again over here to the side just to remind myself, hey, I already have 2 out of my 4 solutions, 0 and 1/2. All right, just a quick reminder of synthetic division. You take your 0, your factor, whatever you want to call it, you put that on the shelf, you bring down your coefficients. Now, in most cases here, I don't think you're going to have to worry too much about missing any terms, but just do remember, if you're missing, let's say we were missing the x squared, we would need to put a 0 right there where that -3 is if we were missing the x squared term. So just don't forget details like that. You're not really going to have to worry about putting them in order, but there may be something missing. Remember, we leave that line there. We bring down that very first coefficient of 2. We multiply it by what's on the shelf. 2 times 1/2 is 1. And we add. -3 plus 1 is -2. We repeat the process. -2 times the number on the shelf of 1/2 gives us -1. We add. 5 plus -1 is 4. Repeat the process. 4 times 1/2 is 2. When we add, we get 0. Remember that last term was our remainder. That's what we're expecting because 1/2, they told us, it is a 0. So when we do synthetic division, we should get 0 as the remainder. Now, the whole point of doing this synthetic division was that when you do synthetic division, you reduce your polynomial by a degree. So we started with 2x cubed. So our answer is 2x squared minus 2x plus 4. And that's the polynomial that we have left when we factor out that 1/2, 0. Okay. Now we have something that we can use the quadratic formula on because that is, it's a quadratic. And we know that it's not factorable because we don't have any more zeros, real zeros. Because this polynomial only crossed the x-axis twice, so we know the other 2 are imaginary. So here we go with the quadratic formula again. The opposite of b was already negative, so it becomes positive. plus or minus the square root of b squared, positive 4, minus 4 times a times c, all over 2 times our a. Let's see here, 4 minus 32 is negative 28. So reducing what's under our square root, first of all, it's got an I because there was a negative under there. 28 is 4 times 7. The square root of 4 is 2. 7 is not a perfect square, so the 2 comes out, the 7 stays under. These three coefficients are all divisible by 2. So that reduces to 1 plus or minus I square root of 7 over 2. You have to have this 1 in the front. Okay. I know in most cases, if it's just a 1, we can drop it. But since it's got that plus or minus following it, if you just drop it, then it's like 0 plus or minus I squared root of 7, which is not correct. It's got to be 1 plus or minus that value. So those are our two other roots. So a little bit more involved of a process, even though the first 2 0, 1 was given and 1 was very easy to find. Getting the other 2, you got to do synthetic division and then the quadratic formula. So look at number 25, similar scenario here. First things first, all of those terms have an x, so we pull out that x. We get x cubed plus 11x squared plus 18x minus 18. So x equals 0. One solution, x equals negative 3. Other solution that was given to us. If we looked at the graph, we would see that it crosses at those two places. Again, that would be a factoring by grouping problem, but we're not going to get the same linear factor, so we go to synthetic division. This one is going to have coefficients of 1, 11, 18, and negative 18. Synthetic division is a neat little process, but it is very sensitive. You got to make sure that you get your signs all right and that you don't miss any terms. There's just a lot of details you have to be careful with synthetic division. So bring down the 1, multiply by the number on the shelf, add, multiply, add, multiply, add. You better get 0 at the end. Now, y'all know that synthetic division does not always result in a remainder of 0, but in these cases it should, because negative 3 is a 0. We reduce the degree, so that becomes x squared plus 8x minus 6. Again, you can try and factor it, but these are not going to be factorable. So we go to the quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Let's see here. This one is not imaginary. It's just irrational. 64 plus 24 is 88. Let's see here. 88 is divisible by 4. I guess that's it. Yeah, 4 times 22. So that's 2 square roots of 22 over 2. And all 3 of these are divisible by 2, so we get negative 4 plus or minus. Now you can leave the 1 out here and in the denominator. You just can't leave it out if it's that first coefficient there, constant rather, if that simplifies to 1, you got to keep that 1. But you don't need the 1 in front of the square root, and you don't need to divide by 1. So there's the other 2 solutions. Any questions? All right, I got one extra problem that I want to add. This is not on your worksheet. It's just got one other little scenario that we need to talk about. So if you want to put it on the margin of your paper or on another sheet of paper, whatever you want to do, I mean, it goes with it. It's just a slightly different scenario. So our function is 3x to the fourth minus 13x cubed plus 12x squared. And while y'all are copying that down, I'm going to go ahead and graph it. Oops. There we go. Okay, so I'm going to go ahead and switch to the graph, but the equation's over there on the left. You can still see it. So when I graph this one, fourth degree polynomial, so I'm expecting 4 solutions, hopefully 4 x-intercepts, but not always. When I look at the graph, I see one x-intercept here at 0, and I see another one at 1.333, so 1 1/3, or what would that be, 4/3? Okay, so there are 2 places where this one crosses, but it's a 4th degree polynomial. So let's see what's going on with this. Let's go algebraic for a second. 0 is equal to, they all have a common factor of, this time it's not just x, it's x squared. So when we come over here to the side and we set x squared equal to 0, since it's x squared, that means there are several different ways that you can see this referred to. You may see it written as x equals 0 multiplicity 2. Okay, this stands for multiplicity. You should have heard that terminology in Math 3. It means that it is a repeated root because it's x squared. That's really like x times x equals 0. So you've got x equals 0 and x equals 0. It's repeated. You may also see it referred to as a repeated root at x equals 0, or sometimes people call it a double root. All those terminologies mean the same thing. So most likely the multiplicity terminology is going to come up, but I have seen the repeated and the double term as well. So I just want to make you aware of those. So that's 2 out of our 4 right there. Let's go back to the graph for just a second. Look at how this differs from the x-intercept of 1.333. The one at 0 just touches the x-axis. It does not cross the x-axis. So when you have even multiplicity, and this is an idea that's shared in Math 3, when you have even multiplicity, so this one had multiplicity 2, you touch the axis, you don't cross the axis. All right, let's go back over here to our quadratic. And let's see here, is this one factorable? I don't think that it's factorable. So let's set up our quadratic formula. X equals negative b, so 13 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so 169, I'm not going to challenge myself. Now, 169 minus 144 is 25. Oh, this is totally factorable. What was I thinking? Oh well, good opportunity to show you how it still works out. So let's see here. We've got 25 is a perfect square. Square root of 25 is 5. So what we've got here is we have 13 plus 5 divided by 6, and we've got 13 minus 5 divided by 6. So 13 plus 5 is 18. 18 divided by 6 is 3. 13 minus 5 is 8. 8 divided by 6 reduces to 4 over 3. Let's go back to the graph for a second. Oh, guess what? I was so zoomed in that I didn't see that it crosses over here at positive 3 and at 4/3. So 1, 2, 3, 4. 4 zeros. This was factorable. I was just not thinking. That would be what? 3x and x and 4. Nope, not 4. It is a minus and a minus. Let's see here. 3 and 4. 3 and 4. There we go. Because we get negative 9x and negative 4x. That's the negative 13x. So obviously this would have gotten us there a lot faster. X equals 3, 3x is equal to 4, so x is equal to 4/3. But just a good opportunity to prove to you that if you look at something, you think it's not factorable, the quadratic formula always works. But what's going to happen is if it was factorable, you're going to end up with a perfect square here under your square root. And so then you can break down your answer there, and you'll get to the same things. It's just a whole lot faster if you recognize.